Hello dear students, welcome to EPG Pathshala. I am Dr. D.C. Saxena, Professor and Head of the Department of Food Engineering and Technology at Sant Longowal Institute of Engineering and Technology, Longowal. I am here to present the paper Technology of Spices and Condiments. In the present module, you will be explained the importance of the process drying in the case of chilies. The drying is a very important step as the water is removed in this process, and because of drying we are able to produce the chili powder. This will be explained by my co-author Mrs. Aarti.
Hello students, welcome to EPG Pathshala. I'm Khan Nadia from Sant Longwal Institute of Engineering and Technology on behalf of Miss Aarti. Today I'm going to talk about Module 14 of paper number 10, Technology of Spices and Condiments. In this module, we will be learning about drying of chilies. In world, there are more than 400 different varieties of chilies. Drying chili peppers is an ideal way to preserve an abundant harvest or leftover supply for future use. Dried chilies are very versatile, and when done correctly, you can use them as it is or reconstitute them in water. Either way, drying chili peppers provides you with an additional way to utilize this incredible vegetable. There are different methods of chili drying, which include traditional sun drying, second, improved CFTRI method of sun drying, third, artificial drying or mechanical drying, fourth one is solar drying. Now, traditional sun drying. It's the most commonly used method in the world. It's simplest and cheapest method. The major advantages of sun drying are low capital and operating costs, and the reality that little expertise is required. Traditionally, this has been achieved by sun-drying fruits immediately after harvest without any special treatment. Sun-drying remains the most widely used method throughout Asia, Africa, Central and South America. The major problem with this method is dust and dirt are blown onto the crop, and unexpected rainstorms can wreck the crop. Second method is CFTRI method. In improved CFTRI method of sun drying, rate of drying is fast, and hence drying period is only a week. This is fast and improved method of drying. Third method is artificial or mechanical drying. This has advantage over traditional sun drying in producing a better and more consistent quality product, taking less time and further minimizing crop losses. Fourth method is solar drying. Due to the current trends towards higher cost of fossil fuels and uncertainty regarding future cost and availability, use of solar energy in food processing will probably increase and become more economically feasible in the near future. Solar dryers have some advantage over sun drying when correctly designed. They give faster drying rates by heating the air to 10 to 30 degrees Celsius above ambient, which causes the air to move faster through the dryer, reduces its humidity, and deters insects. In this module, I will be discussing harvesting, precautions during harvest and post-harvest, methods for drying, which include traditional sun drying, improved CFTRI method of sun drying, artificial or mechanical drying of chilies, and solar drying. Further, the types of solar dryers. Chili is one of the most important trade crops of India. It's grown almost all over the country. In world, there are more than 400 different varieties of chilies. It's also called as hot pepper, cayenne pepper, sweet pepper, bell pepper, etc. The botanical name of chili is Capsicum annuum. Different varieties are grown for vegetables, spices, condiments, sauces, and pickles. Chili occupies a significant place in Indian diet. It is a vital item in the kitchen as it's consumed daily as a condiment in one form or the other. The Scoville scale is the measurement of pungency of chili peppers or other spicy foods reported in Scoville heat units, a function of capsaicin concentration. The scale is named after its creator, American pharmacist Wilbur Scoville. His method, devised in 1912, is known as Scoville organoleptic test. In 2013, Guinness World Records declared the Carolina Reaper to be the hottest chili in the world with an average heat of about 15,69,300 Scoville heat units. Harvesting. Harvest is the process of gathering mature crops from the fields. It marks the end of the growing season. Correct harvesting techniques are the most important factor in the production of a high quality final product. For processing, chilies should not be picked until it starts going red. Chilies get ripe at 14 to 16 weeks after transplanting depending on temperature. Well matured and partially within plant itself. Harvesting and post-harvest handling. There are some precautions which should be taken during harvesting to produce high quality final product. These are: harvesting should be done during early hours of morning. During rains or just after rains, harvesting should be avoided. While harvesting fruits, care should be taken to hold stalks firmly and fruit should be pulled upward gently, breaking the base of the stalk. For dry chilies, care should be taken that the fruit should not be ripened or over-ripened. The harvesting should not be delayed because delay in harvesting gives poor quality produce. The harvested fruits should be heaped indoor for 2 to 3 days so that the incompletely ripe fruits allows the whole produce to develop a uniform red color. The temperature 22 to 25 degrees Celsius is best for ripening and direct sunlight is to be avoided because it can produce white patch in the chili. The ripened pods should be dried in the sun, spreading them on clean, dry polythene sheets cemented drying yard. The moisture content should be kept at 8 to 10% for dry pods. Reverting solar dryers are used for drying. These help in reducing of drying time. Chillies should be staked at 50 to 60 centimeters away from the wall. Periodic fumigations during storage with methyl bromide and phosphine is useful to control insects. The product should not be stored for longer period except in case of cold storage with moisture-proof plastic liners, preferably between 0 to 10 degrees Celsius with 65 to 70% humidity. If possible, while transporting from field, plastic field crates in places of sacks may be used to avoid mechanical damage. Methods of drying. First method is traditional sun drying. In this type, drying takes place by storing the product under direct sunlight. Second method is improved CFTRI method of sun drying. Third is artificial drying or mechanical drying method. This has the advantage over traditional sun drying in producing a better and more consistent quality product, taking less time and minimizing crop losses. Fourth method is solar drying. Solar food drying can be used in most areas, but how quickly the food dries is affected by many variables, especially the amount of sunlight and relative humidity. Typical drying times in solar dryers range from 1 to 3 days depending on sun, air movement, humidity, and type of food to be dried. Now coming to traditional sun drying. It's the most commonly used method in the world. It is simplest and cheapest method. The major advantages of sun drying are low capital and operating costs and the reality that little expertise is required. Traditionally, this has been achieved by sun drying fruit immediately after harvesting without any special treatment. Sun drying remains the most widely used method throughout Asia, Africa, Central and South America. Chilies on harvesting have a moisture content of 65 to 80% depending on whether partially dried on the plant or harvested while still succulent. This must be reduced to 10% to prepare dried spice. Traditionally, this has been achieved by sun drying of fruits immediately after harvesting without any special form of treatment. Sun drying even today is the most widely used method in the world. Immediately after harvesting of fresh fruits, they are heaped indoors for 2 or 3 days so that the partially ripe fruits, if any, are ripened fully and whole produce develops a uniform red color. The best temperature for ripening is 22 to 25 degrees Celsius and direct sunlight should be avoided, which can cause development of white patches. Heap fruits then spread out in the sun on hard, dry ground or on concrete floors or even on the flat roofs of houses. Frequent stirrings are given during daytime in order to get uniform drying and thereby no discoloration or mold growth. The drying fruits are heaped and covered by tarpaulins or gunny bags during nights and spread during daytime. Drying by this procedure takes 5 to 15 days depending on prevailing weather. Out of 100 kg of fresh fruit, 25 to 35 kg of dried fruits may be obtained. The traditional methods of harvesting and sun-drying chilies and capsicums outlined above have many disadvantages, not least in regard to produce quality. Poor handling of fruits prior to drying can result in bruising and splitting. In bruising, discolored spots on pods and splitting leads to an excessive amount of loose seeds in a consignment. There is a considerable loss in weight if dried fruits are sold without seeds. Neglect in provision of adequate drying platforms and protection from rain and pests can result in high losses and contamination, and if not dried properly, the fruits lose their color, glossiness, and pungency. Improved CFTRI method. CFTRI has developed a 4-tier system of wire mesh trays or a single tray of perforated aluminum. It took 14 days in sun to dry fruits having a moisture content of 72 to 74%, reducing it to about 6%. The traditional method of sun drying takes about 3 weeks to achieve a moisture level of 15 to 20%. The improved CFTRI technology involves the following step. Dip fresh chili in dipsol emulsion for a short period, approximately 5 minutes. Dipsol is a water-based emulsion containing potassium carbonate 2.5%, refined groundnut oil 1%, gum acacia 0.1%, and butylated hydroxyanisole 0.001%. Drain excess emulsion. For 100 kg of fresh chilies, 15 liters of emulsion is required, which costs rupees 4 only. Spread the material for drying on racks having multi-tier wire net trays at the rate 5 to 10 kg per meter square of tray area depending upon ambient temperatures. The treated material dry to the commercial level moisture content in about a week's time. There are advantages of improved CFTRI method or traditional method, and these are: the rate of drying is fast and hence time taken for drying is only a week, as compared to 15 to 21 days in the traditional method of sun drying. It requires less space. This method helps in better retention of color and pungency. It gives a more hygienic and superior quality product. It gives a higher yield of finished product 2% more due to minimum breakage and loss of seeds. The improved method adds extra material cost to finished product. Field demonstration using Bivapur variety of chilies have shown that red chilies sun-dried by the improved method brings an additional economic benefit of Rs 50 per quintal. Artificial drying or mechanical drying of chilies. This method has the advantage of traditional sun drying in producing a better and more consistent quality product, taking less time and minimizing crop losses. Optimum conditions for artificial drying. Slicing or splitting pods reduce the drying time by half, and that there was no loss of initial color on drying for 72 hours at 60 to 75 degrees Celsius. Drying of sliced pods was found to have considerable advantage over whole pods. Drying time was much reduced by 50% and a superior initial color was obtained. The optimal drying temperature for a good quality product was found to be 65 degrees Celsius. Single layers of succulent whole fruits dried to 8% moisture content in 12 hours and in 6 hours when in sliced form. Pods harvested when partially dried on plant took even shorter time for curing and exhibited even better quality characteristics. Extended drying was considered permissible at 50 degrees Celsius and at 65 degrees Celsius, but at 80 degrees Celsius, a lowering of pungency of initial color and color retention properties were encountered. However, freshly harvested chilies should be dried on the same day in thin layers at lower temperatures. Chilies dried at 60 degrees Celsius turned black and lost part of their pungency and glossiness. Hence, temperatures 45 to 50 degrees Celsius is suitable. Solar drying. Due to current trends towards higher cost of fossil fuels and uncertainty regarding future cost and availability, use of solar energy in food processing will probably increase and become more economically feasible in the near future. Solar dryers have some advantage or sun drying when correctly designed. They give faster drying rates by heating the air to 10 to 30 degrees Celsius above ambient, which causes the air to move faster through the dryer, reduces its humidity, and deters insects. The faster drying reduces the risk of spoilage, improves quality of the product and gives a higher throughput, so reducing the drying area that is needed. However, care is needed when drying fruits to prevent too rapid drying, which will prevent complete drying and would result in case hardening and subsequent mold growth. Solar dryers also protect foods from dust, insects, birds, and animals. Solar dryer can be constructed from locally available materials at a relatively low capital cost, and there are no fuel costs. Thus, they can be useful in areas where fuel or electricity are expensive. Land for sun drying is in short supply or expensive. Sunshine is plentiful, but the air humidity is high. Solar food drying can be used in most areas, but how quickly the food dries is affected by many variables, especially the amount of sunlight and relative humidity. Typical drying times in solar dryers range from 1 to 3 days depending on sun, air movement, humidity, and the type of food to be dried. Now, coming to the types of solar dryers, there are mainly three different types of solar dryers, which include: first, direct absorption dryers; second, indirect or convection dryers; third one is the combine of both direct and indirect dryers. Now explaining them one by one. Direct absorption dryer. It's the absorption or hot box type dryer in which the product is directly heated by sun. Second one, which is indirect or convection dryer. The indirect or convection dryer is such in which product is exposed to warm air, which is heated by means of a solar absorber or heat exchanger. Then the third one, which is combined direct and indirect. These are the dryers combining the principles of the above two, where the product is exposed to the sun and a stream of preheated air simultaneously. Direct absorption dryers. Direct drying consists of using incident radiation only, or incident radiation plus reflected radiation. Most solar drying techniques that use only direct solar energy also use some means to reflect additional radiation onto the product to further increase in temperature. An example of direct absorption dryer is the hot box dryer as shown in figure. The aim of this type of dryer is mainly to improve the product quality by reducing contamination by dust, insect infestation, and animal or human interference. It consists of a hot box with a transparent top and blackened interior surfaces, ventilation holes in the base and upper parts of slide walls maintained a natural air circulation. Indirect or convection dryers. In above figure, a greenhouse type drying chamber is shown. The main idea behind this type of a dryer is to obtain a low-cost multi-product system. This leads to choose a drying chamber able to accommodate different kinds of trays and act in itself as a solar collector. The drying chamber has the shape of parallel piped with its longitudinal axis in the north-south direction. A wooden frame supports a transparent polycarbonate hollow plate 4.5 mm thick. The wooden skeleton and polycarbonate plates are screwed together, allowing the whole chamber to be disassembled easily. The construction is modular to permit variations of the drying chamber capacity. Trays have a shape that they can be piled easily without crushing the fruits and allow air circulation between them following the main axis. Four small windows located at the far ends of the chamber enable introduction of measuring devices and also control the air renewal in the system. 8 fans placed inside chamber produce an internal recycling and cause the air flux to be uniform. The drying system has 6 solar collectors made of blackened iron plate protected by a glass cover, which also helps to decrease heat losses. Storage of dried chilies. Storage has a marked influence on the color of dried chilies, though it has little effect on their pungency, since color which a producer receives and it may be months before the dried ground product reaches consumer. The problem of loss of red color during the necessary storage period is one that needs to be cared of. The greatest influence on color retention is not in fact of the storage conditions, but rather of the variety of capsicum or chili grown. Or a 6 months storage period for ground material, one variety retains 78% color, whereas another suffers complete color loss. The controllable factors from harvesting onwards that are significant with regard to color retention of the dried spice are as follows. Delaying harvesting until pods are partially withered on the plant and then curing sliced pods is considered to provide product with superior color retention properties. The initial color of dried product, however, does not appear to have a marked influence on the subsequent rate of color loss. The color of ground chilies deteriorate faster than whole or sliced pods on storage, but the latter quickly lose color on eventual grinding. Exposure of dried chilies to air and light accelerates rate of bleaching, and so storage in airtight containers, however, showed no significant difference in color retention samples in bottles showed surface bleaching and those in tins faded more uniformly. When ground chilies were stored with 9 to 10% moisture, the color retention was better than samples with a moisture below 7% samples. With a moisture content of 11 to 12.9% retained a higher color, expressed as beta-carotene content than in samples with moisture below 9%. However, samples stored at 11 to 12% moisture turned black and those stored below 7 turned pale. The storage temperature has a greater influence on color retention than does light air kind of containers or when the spice is stored in the whole or ground form. Storage at 37 degrees Celsius was found to accelerate color loss but is parallel that occurring at 25 degrees Celsius. Refrigerated storage at 5 degrees Celsius shows rate of discoloration but does not affect the inherent color stability of particular capsicum cultivar. On regaining ambient temperature, the refrigerated material suffers a quicker color loss than corresponding unchilled material. This rapid color loss corresponds possibly with shelf life time of retailers. Major storage pests and their control measures. Dried chilies, when stored, are often attacked by drugstore beetle, Ticobium panaceum, and cigarette beetle Lesioderma sericon. The Ardbrodis species also feed on chilies, though the loss caused by them is negligible. Spreading chilies in thin layers and exposing them to sunlight will eliminate the infection if infested by storage pests. If large quantities are infested with these pests, fumigation is the only remedy. In world, there are more than 400 different varieties of chilies. In 2013, Guinness World Records declared the Carolina Reaper to be the hottest chili in the world with an average heat of about 15,69,300 soil heat units. Traditional sun drying, improved CFTRI method of sun drying and solar drying are the methods of chili drying. The traditional method of sun drying takes about 3 weeks to achieve a moisture level of 15 to 20%, whereas in improved CFTRI method of sun drying, rate of drying is fast and hence the drying period is only a week as compared to 15 to 21 days in traditional method. Due to present trends towards higher cost of fossil fuels and insecurity regarding future cost and availability, use of solar energy in food processing will probably increase and become more economically feasible in the near future. Solar dryers have some advantage over sun drying when rightly designed. So, students, let us now summarize what we have learned in this module. Traditional sun drying, improved CFTRI method of sun drying, and solar drying are the methods of chili drying. The traditional method of sun drying takes about 3 weeks to achieve a moisture level of 15 to 20%, whereas traditional sun drying is the most commonly used method in the world. Its simplest and cheapest method. The major advantages of sun drying are low capital and operating costs and the reality that little expertise is required. Sun drying remains the most widely used method throughout Asia, Africa, Central and South America. In improved CFTRI method of sun drying, rate of drying is fast and hence the drying period is only a week as compared to 15 to 21 days in traditional method. This method requires less space. It gives a more hygienic and superior quality product by better retention of color and pungency. It also gives a higher yield of finished product due to minimum breakage and loss of seeds, almost 2% or more. Due to present trends towards higher cost of fossil fuels and insecurity regarding future costs and availability, use of solar energy in food processing will probably increase and become more economically feasible in near future. Solar dryers have some advantage over sun drying when rightly designed. Typically, drying times in solar dryers range from 1 to 3 days depending on sun, air movement, humidity, and also the type of food to be dried. That's all about drying of chilies. Thank you.
Dear students, now the process of drying of chilies has been explained by my co-author. Drying is a very important step in the processing of chilies. Now the next step is its quality. So the next module will be explained to you with respect to quality attribution of chilies. Thank you.